we're told that f of x is equal to 1 over the square root of x plus 1. And what we want to figure out is what is the second degree Maclaurin polynomial of f. And like always, pause this video and see if you could have a go at it. So let's remind ourselves what a Maclaurin polynomial is. A Maclaurin polynomial is just a Taylor polynomial centered at 0. So the form of this second degree Maclaurin polynomial, and we just have to find this Maclaurin expansion until our second degree term, it's going to look like this. So p of x, I'm using p for a polynomial. It's going to be our f of 0 plus, and we could view that as f of 0 times x to the 0 power. Well, that's just f of 0. F of 0 plus f prime of 0 x plus f prime prime of 0 divided by, we could think of it as 2 factorial, but it's really just 2. We could think of this as dividing by 1 factorial, which is just 1. This dividing by 0 factorial, but that's just 1 again. So we have f prime prime of 0, the second derivative evaluated at 0, divided by 2, x squared. Now, if we wanted a higher degree, we could keep on going, but remember, they're just asking us for the second degree. So this is the form that we're going to need. We're going to have these three terms. So let's see if we can evaluate these. Let's see if we can evaluate the function and its derivatives at 0. So f of 0 is equal to 1 over the square root of 0 plus 1. Well, that's 1 over the square root of 1, the principal root of 1, which is positive 1. So that's just going to be equal to 1. So that right over there is equal to 1. Now let's evaluate f prime of x, and then I'll evaluate f prime of 0. F prime of x is equal to, well, 1 over the square root of x plus 1, this is the same thing as x plus 1. Let me write it this way. This is the same thing as, let me write it down this way. F of x, another way of writing f of x is, this is the same thing as x plus 1 to the negative 1/2. And so if I'm thinking the first derivative of f, well, I could use the chain rule here. The derivative of x plus 1 with respect to x, well, that's just going to be 1. And then I'll take the derivative of this whole thing with respect to x plus 1, and I'll just use the power rule there. So it's going to be negative 1/2 times x plus 1 to the, and I decrement the exponent, negative 3/2. And so the first derivative evaluated at 0 is just negative 1/2 times, if this is 0, 0 plus 1 is just 1. 1 to the negative 3/2. 1 to the negative 3/2 power. Well, that's just going to be 1. So this whole thing, f prime of 0, is just negative 1/2. So that is, this right over here is negative 1/2. And now let's figure out the second derivative. All right, I'll do this. Let me do this in this green color. So the second derivative with respect to x, well, I do the same thing again. The derivative of x plus 1 with respect to x, that's just 1. So I just have to take the derivative of the whole thing with respect to x plus 1. So I take my exponent, bring it out front. Negative 3/2 times 1/2 times negative 1/2 is going to be positive 3/4 times x plus 1. And then I decrement the exponent here by 1, or by 2/2. So it's going to be negative 5/2. And so the second derivative evaluated at 0, well, if this is equal to 0, you're going to have 1 to the negative 5/2, which is just 1, times 3/4. It's just going to be 3/4. So this part right over here is 3/4. And so you're going to have 3/4 divided by 2. 3/4 divided by 2 is 3/8. So our Taylor, or I should say our Maclaurin polynomial, our second degree Maclaurin polynomial, p of x, is going to be equal to, and I'll do it in the same colors, it's going to be equal to 1 plus, or maybe I'll just write it as minus 1/2, minus 1/2 x plus 3/8 x squared, plus 3/8 x squared. And we are done. There you have. We have our second degree Maclaurin polynomial of f, which could be used to provide an approximation for our function, especially for x's near 0.